So another aspect of matter is its classification. And so in this section, we're going to talk about elements, compounds, and mixtures. We'll look at the words associated with each of these classifications, how we would know what is what, and we'll do some examples. So on this first slide, I have this flow chart that kind of helps me, anyway, associate these different words, element, compound, or mixture, with each other. So on the top, we have matter, right? And remember, matter is just everything. So it's just the stuff things are made of. It's everything. And so we can divide matter into both pure substances or mixtures. So see, that's how they go together when we talk about pure substance versus mixtures. And the words elements and compounds, notice they're a part of a pure substance side. And then mixtures can be described in two predominant ways with the words homogeneous and heterogeneous. Now notice over here on the pure substance, the word homogeneous is also used. So the first thing we're going to do is define what homogeneous and heterogeneous are and what those words would tell us when we're thinking about matter. So the word homogeneous I associate with looking uniform. So for example, if I dissolved salt into water, the appearance would be as if it's one thing, right? It really just looks like water when I dissolve salt into water, but it's salt water. So that has a uniform appearance. So salt water could be described as homogeneous. Now, the other thing about homogeneous mixtures is not only are they uniform in appearance, but they're uniform in properties, which means if I had a glass of salt water, the salt water would be the same at the beginning of the top of the glass, the middle of the glass, and the end of the glass. The composition of that mixture would be uniform throughout your sample. So associate the word homogeneous with a uniformity in looks and in properties. Now the word heterogeneous, it consists of two or more physically distinct phases, or I like to think of regions. So this is something that you can see the different components of whatever you're looking at. So it could be something like having salt and pepper together. That would have distinct regions. Or it could be something where you have the same substance, but you have ice and water together. Ice water could also be described as heterogeneous because you have an ice cube, which I can see is independent of the water that it's in. So homogeneous is describing, again, something that's uniform throughout, both in appearance and properties. And heterogeneous is describing something that has distinct areas, so you can distinguish the different components in something. It could be a mixture, or like in the case of ice water, we'll see that's going to be a compound. We'll get into the definitions of and differences between pure and mixture in the next slide. We also can describe something as having a phase, and this is just a homogeneous part of a system that then is separated by other parts of a system. So again, ice water would have two phases, right? It has the solid ice and the liquid water. So ice would be one phase because it's a homogeneous part, and then water would be a second phase. So a phase is just speaking about one part of a system. So let's now, with those words homogeneous and heterogeneous, which again are describing an appearance or what we can see, let's talk about the differences between a pure substance and a mixture. So if you look here, pure substance, it's important, composed of only one substance. I might get a different color for my pen. So composed of only one substance, and then it cannot be physically separated. Physically separated would be things like using a filter. let me see, filtration. So if I had sand and water, and I put it through like a coffee filter, I could physically separate the water and the sand because the sand would get stuck in the filter and the water would go through the paper. Or something like I could evaporate. If I had salt water, I could evaporate the water off, and that would leave the salt. These are things that are physical separations because it does not rely on a reaction. So a pure substance is something that contains only one type of matter. One type of matter. Now, what it can be is an element or a compound. And we will, in the next slide, distinguish between elements and compounds. Okay, so that's the next slide. But what we need to know now is pure substances contain only one type of matter, and the things that can only have one type of matter would be an element or a compound. Now, mixtures are exactly what you would think they would be. We don't redefine mixture for chemistry. So this is a physical blend, which is just implying that there's not a reaction. So sometimes you put chemicals together and they react. That's not a mixture. In a mixture, you put chemicals together and they sit side by side. So when you mix two or more substances, okay, so it'd be two or more pure substances, they will form a mixture. And you can physically separate them. Again, thinking about salt water, you could evaporate the water and get the salt. So there's ways to separate them. And we describe mixtures as homogeneous or heterogeneous. So from this slide, what I want you to be considering is knowing the definitions and be able to apply. So pure substance, which only contain one type of substance. It could be an element or a compound. And a mixture is when you take those pure substances, elements and compounds, and you place them together. And there's not a reaction, but they come together either homogeneously, where they look uniform like salt water, or heterogeneously like salt and pepper, where they mix, they're sitting side by side, but they're not homogeneous. You can see the distinct regions. Now, in the next two slides, first we'll distinguish between elements and compounds, and then we'll distinguish between homogeneous mixtures again and heterogeneous mixtures. So we'll reapply those words. So pure substances can be elements or compounds. And so let's look at the elements. So the elements are only a single type of atom. So it can only have one kind of atom. Now, atoms are the building blocks of chemicals. Now, there are smaller particles than atoms, but those smaller particles don't have chemical properties. So for a chemist, while we consider the smaller particles because they help us understand what's going on, in terms of reactions, we're really thinking about the atoms, the smallest particles, as the building blocks. Now, where we can find these atoms are on our periodic table. So if something's not on the periodic table, it is not an element. The element is like a library of the periodic table, is the library of all of the elements. So elements only have one kind of atom. They're the building blocks, and we cannot break these down with chemical reactions. Okay, so they can do things with physics and physically to do things to atoms, but in a reaction, the atom is the smallest it's going to go. And there's just some examples: copper, oxygen, sodium, chlorine. At this point, you might think to yourself, do I know the symbols for those, which we haven't talked about yet, but in the first day of class, I said, I'm going to have you know some names and symbols, and these four are ones that you should know, and I wrote the symbols just so you can be testing yourself. Now, a compound occurs when two or more atoms are bonded, and bonded is the word we use in chemistry to say they're attached to each other. So two or more different atoms are bonded together. They are attached. They have a fixed proportion by mass. I always think of this, especially at this point in the semester, and we'll get more into the proportion by mass later. But I always think, for example, if I ask you, what is the formula for water? You might have thought it already in your head and said, oh, it's H2O. Okay, that is water's fixed proportion. So water has 2 hydrogen atoms, and if there's no number, it's one oxygen atom. And the bonding of those atoms together make water. And water can't have a different proportion and still be water. So every compound has its own fixed proportion of the atoms by mass. Now, we can break down the atoms into their elements using chemical reactions. So compounds can be chemically broken back down into their elements. And I have examples here. I have water, which they all have formulas. Now sugar, I'm going to write the formula for glucose. Sugar is a pretty general term. There's several sugars, but this will be glucose. Carbon dioxide, which is CO2, and sodium chloride, which is NaCl. So notice the formulas for compounds all involve more than one atom. Okay, so your goal is to be able to try to distinguish between elements and compounds. And I have a couple practice at the end of the slides. So before we move on to our practice, let's classify some mixtures. So mixtures, remember, this is a definition that you will probably be familiar with. It's just when you combine two or more pure substances. And it's, maybe I'll say in here, let me add the word a physical combination, not a chemical reaction. So we can describe something as homogeneous, and here we have a picture of it's probably salt water or sugar water. Homogeneous mixtures are uniform throughout, and we refer to them as a solution. Solid solutions are called alloys. So when you mix metals together and you want it to be homogeneous, you have to first put them in a molten state, which is like a liquid metal, mix the metals, and then re-solidify them, and then it will be uniform throughout. So if you see the word alloy, this is a homogeneous mixture of different metals. So some examples of homogeneous mixtures I have here are salt water, 14 karat gold. So pure gold is very soft, so they add some other metals to give it a little more strength without losing the prettiness that gold has. And then air, which is gases, but they're gases that are mixed uniformly. Things oxygen, nitrogen, argon. There's some other gases in air. Now, heterogeneous, remember that word describes distinct regions. So heterogeneous is something where you can see the different components of the mixture. So in this illustration on the far right, we just see layers of different liquids. That's heterogeneous. Things that are heterogeneous, well, a solid, something that's heterogeneous might be granite. Like if you think of granite countertops, and you can see the different things that are inside that solid, you definitely see distinct areas, which makes the granite pretty. Things like if you have plants, potting soil, garden soil, it's a mixture of things. And then things like cereal and milk, where you can distinctly see the different parts of the mixture. So I did pull, just as another summary, this was the chart that's from your book. It adds a few other words, like it notes that it's a physical process between pure substances and mixtures. It is compounds and elements. You can see down there, it's a chemical process. They also, in your text, kind of flipped the chart. And they do have some illustrations for you. So I included it just, again, now that we kind of went through some definition, for you to put context on how these things are related. So now I have 4 slides with practice questions. And like we always do with practice questions, I encourage you to pause it, read the question, and then keep going, and I will give you the answer. So let's try. Okay, pause it. All right, so the question is, which one of the following is an element? Classify the others. Okay, so the answer is gold. Okay, so the recording stopped, so I hope that I got what I needed to get. So which one of the following is an element? Classify the others. And the answer here is gold. You can always double check, because if it's on the periodic table, then it is an element. Gold has a symbol of Ag. I'm sorry, Au. Ag is silver. Steel, this is an alloy, so this is a mixture, homogeneous mixture. I'll put homogeneous for clarity. Sugar is a compound. Air is a homogeneous mixture. And carbon dioxide is a compound. This is CO2. Sugar, there's different forms. I'll do glucose again, but there's different forms. They all have carbons, hydrogens, and oxygens, but in different amounts. Okay, so let's try another one. All right, so again, read the question and then pause it, try to answer it, and then I'll answer it. So which one of the following is a homogeneous mixture? So homogeneous is uniform. And on this list, the thing that's uniform is maple syrup. So distilled water is not a mixture at all. It's pure water. So this is a compound. Mercury is an element. It's on the periodic table, number 80, Hg. A granite countertop is a heterogeneous mixture. And Italian dressing is also a heterogeneous mixture. This question did not ask us to classify the others, but I always find it helpful just to keep exposing ourselves to different things. It helps us when we the more we're exposed to, the easier it gets. Okay, so let's try another one. So read the question, pause, and then start again, and I'll give the answer. So which of the following is a heterogeneous mixture? Okay, so the heterogeneous mixture is letter E, granola. So let's just classify the others again, just for practice. So the baking soda is a compound. You don't have to know the formulas. I'm just trying to give you some context. It's called sodium bicarbonate. Gasoline is a homogeneous mixture. Grape juice is a homogeneous mixture. And zinc metal is an element. And zinc has the symbol Zn. So again, the more you expose yourself to these things, the easier it becomes, the easier it is to answer questions on homework and exams and just get a better, broader knowledge. So in the textbook, they have other questions. I have practice worksheets, but there's also other questions in the textbook. If you have time as you're studying, I always encourage you to just keep putting things in front of yourself and just keep trying. So we have one last question in this section, and so you can review it. Again, I would pause and read the question and try to get answers. There are illustrations. This is the copper wire. This is the copper to oxide. We see that. This here is the malachite, and this is the bronze. So pause. Read the question because it has a lot of words, and then I will answer it. All right, so it says review the following properties of the element copper, then fill in the blank with one of the following. So our answer is going to be element, compound, homogeneous mixture, or heterogeneous. So copper metal can't be broken down by a chemical change. Copper wire is an element. Copper reacts with oxygen in the air to give copper oxide. Copper oxide is a compound. And what gives it away here that it reacts. So it's not a mixture. Mixtures are physical. If something reacts together to make something new, that's a chemical that's a compound. Let's see, copper in the form of malachite ore is found worldwide. Malachite ore is a heterogeneous mixture, which I don't know that the words would tell you, but this picture here really does illustrate a nice heterogeneous system right there. And then the last one, copper and tin compose bronze alloy. Look at that word right there. Bronze alloy is a homogeneous mixture. Remember, the word alloy is another word for a homogeneous mixture of metals. All right, so just be sure that you know that the different classifications of matter, and practice being able, given descriptions or different chemicals or different words, to classify where it would go within that whole system of matter.